We all have a basic idea that energy from the sun at the center of the solar system essentially fuels planet Earth. The light and heat emitting from our life-enabling star lays the foundation for our climate and weather systems, as well as encouraging life on our planet to grow. The sun also exerts a gravitational force on us, with the speed we orbit around it prompting how we measure a calendar year. And our fortunate positioning within the solar system's habitable zone comes about thanks to the relationship between the speed at which Earth travels and its distance from the star. But these factors would all significantly change if the sun were twice as massive. So what are the sun's vital statistics at the moment, and how would they change? Right now, it's 865,000 miles across, which is more than 100 times the diameter of Earth, and it boasts a circumference of more than 2.7 million miles. So double that, and we have something that's about 1.7 million miles wide with a circumference of close to 5.5 million miles. Assuming that its mass doubles at the same rate, what's already the biggest thing in the solar system is now even larger. Although incredibly, it'd still only rank as a mid-sized star compared to all across the universe. But what would actually happen at this point, now that the sun has had a growth spurt? Without delving too deeply into particle physics, the sun essentially radiates energy thanks to a process called nuclear fusion. As particles of hydrogen slam together to create helium in the solar core, this actually means that the sun loses mass over time. But were this to continue unchanged in a larger sun, twice the mass and therefore twice the fuel would naturally lead to a brighter and more powerful star. Currently, the sun loses about 4 million tons of mass per second via nuclear fusion, so this would also increase if its starting mass was multiplied by 2. And where does all the extra energy go except where it always does? Out into the solar system. The sun's already the brightest object in the sky, but now it would appear even more luminous across the landscapes of every single planet that orbits it. So more light, more heat, and more power equals a more efficient existence, right? Well, no, definitely not. Unfortunately for Earth in particular, a bigger sun means that the habitable Goldilocks zone is pushed much further out into the solar system. We'd go from being not too warm but not too cold to being incredibly uninhabitably hot. Seas would boil, people would fry, plants would die. The outlook would be in no way good for the continuation of life. In fact, while living on Earth would no longer be viable, even our physical planet itself could find itself free-falling to a fiery end. And that's because Earth would unstoppably plummet towards the sun, since the balance between its velocity and the sun's gravitational pull will have drastically altered. So not only would Earth have been knocked out of the Goldilocks zone as per its current orbital path, but that orbit may well have been disrupted beyond all recognition at all. And as the planet finds its new place around the star, then its tidal patterns change, its rotation speed, and the makeup of its atmosphere. Say though that humanity had in some way developed a means by which to survive such fundamental changes. Perhaps we're all housed in some kind of indestructible building. What would we actually see if we looked out the window? As more and more of the sun's light and energy reached us, the greenhouse effects we currently experience would dramatically accelerate. The polar ice caps would melt at an ever-increasing rate, once green areas would dry and die out, and large-scale natural disasters would become the norm, with tropical cyclones and hurricanes reaching never-before-seen sizes as the temperatures continue to rise. In general, a sudden increase in sunlight could wind up impacting the very way in which clouds and weather patterns form. The water cycle would actually evaporate, and the safest places on Earth would be as deep underground as you could possibly get. And even then, if a colony of humans were able to somehow survive in double the sun conditions, they'd be crossing their fingers that their planet is still able to maintain some sort of stable orbit, without the now supersized star consuming it completely. Back on the surface, we could throw an increased risk of solar flares into the mix of things to worry about. And if that exceptionally hardy bunch of humans is still alive, they'd have very few ways of communicating with one another. The now strengthened flares would disturb communication lines, electricity supplies, and radio waves. We'd be holed up in sweltering conditions underground with little means of growing food or sourcing water, and with no way of facilitating any kind of group effort to get us out of the mess. The outlook isn't quite so bad for planets that orbit further away from the sun, though. And while it's difficult to predict exactly what would happen on the likes of Mars and maybe even the asteroid belt's largest inhabitant Ceres, they'd now most likely be more compliant with life than Earth. So were this hypothetical a reality, here's hoping we'd have developed long-distance space travel to at least try and survive it. But again, as an increase in the sun's mass means an increase in its gravitational influence over every planet, even the likes of Neptune and the dwarf planet Pluto could see their paths changed forever. The central star would appear larger in the skies of every one of our local worlds, and everywhere would be receiving much more energy than it currently does. Perhaps traditionally Earth-bound human beings could find a way to escape elsewhere, to a place that may or may not support life as we know it. Or perhaps in this solar system that's effectively redesigned itself, life would eventually re-emerge in a completely different way, at a completely different time, on a different planet entirely. So double the sun definitely isn't double the fun. Here on Earth, we're exceptionally lucky that our star is the size it is, our planet is the size it is, and both are positioned precisely where they are. But that's what would happen if the sun was 2 times bigger.